Hey guys. I'm going to do a little video here on section 1.3 on geometric sequences. Just got back from a bike ride, so I'm a little tired, but hopefully I'll stay awake during this. I'm going to switch my screen here and switch over to my OneNote here. So hopefully this will be legible for you guys. Okay, we're looking at geometric sequences. This is a sequence where every term in it is being multiplied by a common number. So it's not like an arithmetic sequence where you're adding a certain number each time, but you're actually multiplying one here. I'm going to get rid of my video thing that's put up there. This number that we multiply by is called the common ratio, given the letter R. And the first term is the letter A, just like it was in arithmetic sequences and arithmetic series too. So the pattern here, you can see we have the first term being A, T1's A, T2 is AR, and just gonna that. So T1 is A, and then we multiply by R, so T2 is AR, and then T3 is AR squared. And then it keeps going on. So actually, there's a small typo here. Actually, this is T4, and this is T5. And I'm glad I actually made that mistake because that's shows that I am very tired, actually. But anyway, also what we want to see here is the pattern here. So it seems to be the term number is actually one ahead of the power the R is being raised to. So in T4, we have AR cubed, and then T5 is AR to the fourth. So what do you think TN would be, like the term you're looking for at the end of everything? Well, we know that, so we can create a formula here for this. So we could say the first term is Tn, and our first first number in the pattern is A, and then we're multiplying it by R. And what we now know, I'm going to get rid of my face here, actually. It's bugging me looking at myself. Just get rid of the video. There we go. Okay, my eyes are all bugged out by my allergies. Okay, so the R here then would be raised to the number of times you're timesing by R, and it's always one behind the term you're looking for. So then we would do n minus 1. So we can see T5 would be the A value multiplied by R, and then 5 minus 1, which would be AR to the 4. So I hope that kind of makes sense on our pattern here. So how can we find the common ratio then? Well, one way is if you had two terms, let's just take T4, that would be AR to the 3, so using our formula. Let's say you had term 3, the term before it, that would be AR to the 2. So one way you could do this is divide the two terms from each other. So you could actually divide T4 by T3, and then that would give you, well, A divided by A would be, if you were to divide these terms, so if you said T4 divided by T3, that would give you A divided by A, so the A's would cancel if we divided them. And then you would have R to the 3 divided by R to the 2, which is R to the 1. So let's see if we can maybe use a set of numbers to prove this. Maybe with variables, it looks a bit strange. But here's 3 different geometric sequences. And so let's maybe pause the video and see if you can find the common ratio for these. Okay, so if we take a look at the first pattern, we can almost see the common ratio here. I mean, we're doing 4 to 8 and 8 to 16, but let's use this idea of dividing subsequent terms from each other. So if you did 16 divided by 4, that would give us, or sorry, that's 8 actually. So 16 divided by 8, if I just take those two terms, and that would give us a value of 2. So it seems like we're multiplying by 2. And of course, if I picked any other pair that are sort of right next to each other, so 8 divided by 4, well, that would be 2. And if I did 36 divided by 16, sorry, 32, boy, 32 divided by 16, that would also be 2. So we can see that the common ratio is the same here, which is why this is a geometric sequence. Every term is being multiplied by 2. So we would say the R value here is 2. In the next example, we can see if we take -6 and we divide it by 12, that gives us -1/2. And if I take 3 and divide it by -6, that also gives us -1/2. So assuming this pattern follows, the common ratio here would be -1/2 then. Okay, so our last example of finding the common ratio, if we take T1, T2, and T3, a little bit different with variables here, but if I divide two terms that are come one after the other, so subsequent terms, so if I did T2 divide by T1, that would be 6a cubed divide by 3a. And so the 3's would 6 divided by 3 is 2, and then a cubed divided by a is a squared. So let's see if it's the same for T3 divided by T2, do the same value here. So we have 12a to the 5 divided by 6a cubed. And so 12 divided by 6 is 2. A to the 5 divided by a cubed is a squared. So we can see here that the R value is actually 2a squared. We're timesing that by each term as we move along here. Okay, so here's a question where we're being asked to find maybe the 10th term in a geometric sequence here, where we know this is T1, obviously, T2, I'm going to write kind of small here, T3, T4, and it just keeps on going. And what we're trying to find out is if you did keep on going, what would the 10th term be in this pattern here? So we're going to go back to our formula we created here, which was this one right here. So the nth term in a geometric sequence is AR raised to the n minus 1. So let's use that formula and see if we can work with that to give us an answer here. So we know Tm is equal to AR to the n minus 1. And we know A is our first term, which is 3. And so what's our common ratio here? Well, I know 12 divided by 3 is 4. 48 divided by 12 is 4. And I'm thinking 4 times 48 would be 192. So it seems like our R value here is definitely going to be 4. Now, N is the number of term number you're looking for, which in this case is 10. So we actually have all the information we need to plug in to our formula here. So we're looking for T10. So we would take 3, multiply it by 4, all raised to the 10 minus 1. So this would be 3 times 4 to the 9. And of course, everyone knows 4 to the 9. That's such an easy question, boy. So 4 to the 9 is very large. Times that by 3. I'm going to double check my answer here, but I'm not getting that. 786,432. Let's just try that again. So 4 raised to the 9 times by 3. And notice we did the powers first. We did the base raised to a power, and then we multiplied by 3. Don't do 12 to the power of 9. Like, don't do 3 times 4 is 12 to the power of 9, because that 3 is actually being raised to the first power. Okay, so that does seem to be right. Okay, so example here says we have a fourth term of 125. So I know T4 is 125. And I know T9 is equal to 125 over 32. So it seems like we're probably multiplying by some kind of fraction here. Find the 13th term. So we're like, keep going down the line. And what would T13 be? Now, there's many ways to do this question. One way is actually to make this actually your first term, make that A. And then make this T9. Well, that would be so T4, making that T1. You could make this be T6 then, I guess, right? Minus 3. And then you'd be looking for T10. But I'm actually going to do it not that way. I'm going to just basically work with the terms given to me. So I know that T4 is AR cubed. and that's equal to 125. And I know T9 is equal to AR to this 8, and that would equal 125 over 32. So I'm going to need to find out, well, I know my n value first, so I know n's 13, but I need to find my a value and my r value here. So I'm going to use these two equations together because I got two unknowns, so I need two equations. And what I'm going to do is take the first equation and write it underneath this one. So I'll just change it to blue here, so blue's cool. T4 equals AR to the 3 equaling 125. And now what I'm going to do is I'm going to divide these two equations from each other. So I'm going to divide the two equations. So I'm going to put a division sign here. Now, if I divide a by a, I get 1. R to the 8 divided by r to the 3 would be r to the 5. And then 125, let's do it over here. 125 over 32 divide by 125. Working with fractions, I should flip it and turn it to multiplication. So I'm basically getting 125 by 125, 1 over 32. So I get 1 over 32. Now you might remember from log chapter that 32 is 2 to the 5. So I could fifth root both sides here. So I'll take the fifth root of this side and the fifth root of that side. And so I'm going to get r is equal to 1/2. Now to find my a value, I just plug it into the equation for any one of them, but I might just do both just to confirm that I'm getting the same a value here. So T4 is equal to a times 1/2 cubed equaling 125. And so this would be a over 2 times 2 times 2, so 8 is equal to 125. So a value here would be 125 times 8, which is 1,000. And I'm just going to do a real quick calculation over here to see if I'm getting the same number for the other one. So T9 would be AR to the 8, which is equal to 125 over 32. And actually, I'm going to get rid of that r because I know r is 1/2. So 1/2. So I'll just use my calculator for this here. So I get a is equal to 125 divided by 32 and times by 2 to the 8. So I'm getting 1,000. So it is right. So a is 1,000. So to find out my T13 would be an a value of 1,000 multiplied by 1/2, all raised to the 12th power here. So this would be 1,000 all over, where is it here? 1,000 over 2 to the 12. So that's 4,096. And if we reduce that, I believe that's 125 over 512. So there we go. Okay, so that's kind of a tricky one. We had to set up a system of equations there. Once again, if you want to make the first term a, make this your first term, make this now your sixth term, and make this now your common ratio. You'll actually get the same. Sorry, this your 10th term, I should say. You should get the same common ratio. And if you solve for T10, you'll get the same answer as you did solving for T13. So it's up to you how you want to try that one. So our last question is quite a tricky one, but I know some of you guys are super keeners out there. So we're going to solve for the x value in this geometric sequence. So we're told it's geometric, which means if I take T2 and I divide it by T1, I should get R, because that's really AR divided by A. So that would just be R. And if I take T3 and I divide it by T2, that should also give me R. And that's because it's AR squared divided by AR. So that would be R. Anyway, so that's one way we could do this. So we're going to set up that using these two equations here. So I'm going to draw an arrow over here. So I'm going to say T2 is 3x minus 5 all over T1, which is x. And that has to equal R. But since these r's are the same, these two statements must be equal to each other. So T3 is 4x, and T2 is 3x minus 5. So once again, this is T1, T2, and T3. So I'm just dividing each term by each other because they're both equal to r and setting them equal to each other. So if I cross multiply here, I get 3x minus 5 all squared, timesing it by itself, and I get 4x squared. So we get a sweet quadratic here. So we're going to expand this to 9x squared. 3 times negative 5 is negative 15, so double that, negative 30x plus 25 is equal to 4x squared. So this is really going to be 9 minus 4 is 5x squared minus 30x plus 25. Now all these numbers are, each term is divisible by 5, so let's divide everything by 5. So x squared minus 6x plus 5 equals 0. Look at that nice little equation. We're going to factor that into x minus 1, x minus 5. So that would be the two factors. And then our two roots now would be x equals 1 and x equals 5. Now that's actually the answer to the question, but just to sort of show you the pattern here, if I put these numbers into the equation, my first term could be 1, and then I have 3 times 1 is 3, minus 5 is negative 2, and then 4 times 1 is 4. And then the pattern would keep on going. So it seems like the common ratio there would be negative 2. And if I put 5 in, I would get 5 minus 5 times 3 is 15, minus 5 is 10, and then 4 times 5 is 20. So it looks like my common ratio here is 2. So I have the same common ratio in the first one. And the second one just is positive and negative here. But really the answer to the question was, what is x? And that would be what x is. Okay, so I love Smarties. Actually, my wife likes Smarties. I'm more of an M&M guy myself. But anyway, so they're round, they're chocolatey, they taste good. So we know the first term would be day 1. So day 1. And apparently I can eat 3 Smarties, or I did eat 3 Smarties on day 1. On day 2, I ate 6. And on day 3, I ate 12. So it seems that I'm doubling my Smartie intake every day. So 3 times 2 is 6, times 2 is 12. And this just keeps on going because I am a determined person. And my last day is what I'm being asked to find for. So what day will I eat 6,144 Smarties, which is actually quite a feat. We used to work at the Wax Museum and the candy shop there, which you guys probably don't know about because it's gone. But we had a weigh boat, and we would weigh Smarties, and then we would pour the Smarties into our mouths to see how many Smarties our mouths could hold. It was a lot of fun. Anyway, so here we go. So I know Tn equals ARN minus 1. Basically, in all these questions, you have to find the 3 variables, or maybe you know certain numbers of variables. So A, R, and N, RAN, you could know RAN, or you have to know maybe RNA, ANRA, ANR. But anyway, so those are your 3 variables, however you want to remember that. So I know my first term is A, and that's going to be 3 in this question. So I've got a 3 here. My common ratio is 2. And what I don't know in this question is actually the n value. I don't know what day I'm going to wind up doing this amazing feat. So that's really what we're solving for here. So I'm going to plug that into our formula and see if that helps us with anything. So I'm going to say Tn, the term I'm looking for, would be the first value of 3 multiplied by a common ratio of 2 raised to the power of n minus 1. And that has to equal, well, if it's the term I'm looking for, if this is the nth day, if that's the day I'm looking for, well, then that has to equal 6,144 Smarties. So I'm solving for an exponent. Holy crap. So that's got to be something to do with logs, I think. I love logs. Okay, so what I'm going to do first of all, though, is divide both sides by 3. So I'm going to take 6,144, 6,144, divide that by 3, and that gives me 2,048. Now, you might remember I made you guys memorize powers of 2 up to a certain number, 2 to the 10. And that's just a little bit past that. So you might be able to do this without a calculator and using logs, but I'm going to use logs because, why not? So I need to get the power out of there. So I'm going to log both sides of the equation. So log this side here. And then I'm going to move the exponent in front. Use my power law. So n minus 1 times log of 2 is equal to the log of 2048. And I'm going to divide both sides by log of 2. And I'm going to bring the 1 over. So I'm going to use my calculator for this. Minus 1. So I'm thinking that's got to be an 11 minus 1 here. Let's just take a look here. So log of 2048 divide by the log of 2. So that is 11. So 11 minus 1, which is 10. So it's pretty impressive, but that would mean on the 10th day, on the 10th day, I would be able to do this amazing feat. Anyway, I hope that helps a little bit. That's some of the stuff we've done for geometric sequences. Don't forget, R is your common ratio, A is your first term, and N is the term you're looking for, the nth term of the equation. So we look for RAN when you set up these questions, do them. So I'll assign some questions on the homework section, and I hope that helps. And I guess we'll see you guys in a Zoom meeting soon. Take care. Let's unshare here, and then we're going to stop sharing and stop the